Figure 7 is a velocity time graph for the motion of a van on a long straight road. So I've got velocity on the y-axis, time on the x-axis. The van accelerates at 2.2 meters per second squared. The force causing this acceleration is 5.5 kilonewtons. Calculate the mass of the van. Again, I have calculate, so I'm going to write the equation. The equation I'm going to need is force equals mass times acceleration. So I need to rearrange for mass. You can either do this mathematically, so if I want mass on its own, I need to divide by acceleration. If you prefer to use triangles, force equals mass times acceleration. So I cover up mass. I'm left with force divided by acceleration. So from the question, my force is 5.5 kilonewtons. So that kilo means times 1,000. So this actually equals 5,500 divided by the acceleration, which is just 2.2 meters per second squared. So we can leave that as 2.2. So this is now just in newtons, meters per second. So 5,500 divided by 2.2 in the calculator gives us 2,500 kilograms. Be careful with units, highlight them, underline them, double check you're using the correct units. Part 2 says calculate the distance travelled by the van between 16 seconds and 23 seconds. Give your answer correct to two significant figures. So this 16 seconds is this triangular area of the graph. Now we've got velocity time graph, so the area under the graph equals the distance travelled. So I just need to find the area of that triangle. So triangle is just base times height divided by 2. Now the base of that triangle is the difference between 16 and 23 seconds. So 23 take away 16 equals 7. And then my height is from 0 up to 13. So 7 times 13 divided by 2. So 7 times 13 divided by 2 gives us 46 meters, or 45.5, but it does say two significant figures. 45.5 is what comes out of the calculator. So to two significant figures, 46. So we get a mark for 23 take away 16. We get a mark for inputting the 7 times 13 at the top. We get a mark for dividing by 2. And we get a mark for the two significant figure answer. So if you wrote 45.5, you should still be getting 3 of those 4 marks. Question B is now a 6-mark question. A teacher takes a group of students to a sports field to measure the speed of sound in air. The teacher fires a starting pistol. It produces a loud bang and a flash of light at the same time. The students take measurements. Describe how the measurements are made and used to determine the speed of sound in air. You may draw a labelled diagram to help with your answer. If they give you that option, I always would draw a diagram. So we've got our gun here, and that's going to make a bang and a flash of light at the same time. A distance away, we will have our students, and they will be measuring the time it has taken for that sound to travel towards them. So in terms of actually writing our description, we need to say we need a large distance between the pistol or the teacher and the students. One for safety, but also because the speed of sound is very quick in air, so we need as great a distance as possible to get our results as accurate as possible. I need to measure that distance. So remember it says describe how the measurements are made. So measure the distance using a trundle wheel. They need to measure the time with a stopwatch or a timer. They should start their timer or stopwatch when they see the flash, and stop when they hear the sound. Sound travels much slower than light, so they will see the light almost instantaneously as soon as that gun is fired, but the sound travels slower. So by starting when they see the flash and stopping when they hear the sound, they're measuring the time it takes for that sound to reach them. They can then calculate or determine speed of sound using distance divided by time. They should, as always with practicals, they should repeat or have several students timing to increase accuracy. If lots of students are timing, they could then calculate an average time, and that's going to be much more accurate than just one student timing. Another way they could improve accuracy is by repeating the investigation, but from a different direction. So they are then taking into account the wind direction. But repeats is the easiest way to remember that it increases the accuracy of the practical.